All right. So I guess we're live and we're recording. I'm sure some people will trickle in over the next few minutes, but we may as well get started. Thanks everyone for joining the quarterly Livepeer community call focused on node operators, orchestrators, and transcoders on the network. We're streaming at livepeer.org/TV. We're recording, and it'll be posted online for playback later. So a lot happening in the Livepeer network recently with significantly increased adoption of minutes streamed on the platform and fees flowing through the platform. I think last week we were just shy of our all-time high, which occurred during a kind of a holiday week when there was a lot of kind of evening streaming events back in January. But I think we hit just shy of 500,000 minutes of video streamed and just shy of $5,000 worth of ETH distributed out to node operators on the network. So exciting milestones. I think as a result, we've seen a lot of activity in the kind of transcoder node operator channels in our community, a lot of new entrants setting up nodes, a lot of firefighting with configuration and figuring out how to deal with some of the challenges of gas prices and whatnot. And so I think those are things that we can address on the call today. So the topics that I had on the agenda were this improvement proposal we have to dramatically reduce gas costs when it comes to calling reward and claiming tokens. I want to let Nico give kind of an in-person update and walkthrough on how he set up profitable GPU mining rigs through Livepool and wrote a post about that recently. And I think Yandin is going to share some updates on dual mining integrations with popular Ethereum miners and some results that we're seeing with that we want to publish soon. And then, of course, open for discussion, questions, other topics as we go. So if that sounds good, I guess I'll hand it over to Yandin and Nico to talk about the current improvement proposal.
Sure. So before getting into the improvement proposal, maybe it's helpful to talk a little bit, very briefly, around how some members of the Livepeer team are thinking about blockchain scaling and the rising gas prices on Ethereum. So this improvement proposal that we're about to talk about is very much something that is looked at as something to help with that situation. But taking a step back, just wanted to mention that generally how the problem is being looked at is on 2 time horizons, so the short term and the medium/long term, where what's great is that there are a variety of layer 2 solutions on Ethereum and even outside of the layer 2 technical space, like scaling solutions that the ecosystem is working on. And members of the team are actively researching and doing due diligence to identify the best technology fit for Livepeer so that Livepeer can continue to scale even as adoption of Ethereum increases over time. So that's something that is looked at as very important. It's ultimately needed to address gas prices all around for all actors in the ecosystem, but it likely takes a little more time. So because we want to make sure that it meets the requirements properly, we want to make sure that all the needs of stakeholders within the system are met. So that's something that we're actively working on, doing due diligence for, and hope to identify a roadmap that we can share with the community in the near future. At the same time, we don't want that to be the only thing on the horizon. So that's where this improvement proposal that Doug mentioned comes into play, where we believe that there are still some things that can be done in the short term as we work on getting that bigger scaling solution into play to help at least a subset of the stakeholders within the system, either with financial sustainability or to increase participation in the interim. So that's kind of like the big picture, how this is being looked at. And there's more details in, I think, a blog post that Doug had shared a couple months ago. But yeah, moving into the improvement proposal itself, it's an improvement proposal currently titled LIP 56 that seeks to reduce the frequency at which node operators need to invoke reward, which distributes inflationary LPT rewards not only to themselves, but also to their delegators. And this is a proposal that Nico has been working on a lot in the past couple of months. So Nico, is Nico on the call? Yeah, Nico, if you're on the call, do you want to share a little bit about how you're looking at this proposal right now? Maybe give a high-level overview of what the proposal seeks to accomplish and what the timeline for it looks like right now.
Yeah, sure. So as Jan already mentioned, the current proposal seeks to reduce the frequency at which transcoders or orchestrators have to call reward. We're currently looking at introducing a reward period so that your rewards accumulate during that period and only get minted at the end of that reward period. We're currently thinking of a reward period of 7 rounds. So you would roughly have to claim your rewards once a week instead of once a day. I can maybe give a quick high-level overview of this as well. So the proposal introduces a couple of rules as well when it comes to how much reward you're eligible for a reward period. And those mainly get enforced when you unstake or you add stake during a reward period, or for example, you switch delegators. So for example, if you add stake during a reward period, only your initial stake at the beginning of that reward period will count for how many rewards you will earn. This is true for both delegates as well as delegators. If you unstake during a reward period, only your lowest amount will count. And if you completely unstake, you will forgo your entire rewards for that reward period. The same is true if you switch orchestrators. So those are the basic rules for the proposal, and that's what we're currently working with. So the proposal currently has been shared internally yesterday, and I'm going to post it in the LIP issue itself today, so anyone can review it. And that's basically where we're at in terms of implementation. Once the proposal has been reviewed thoroughly, we can implement it, and I'm thinking about 2 to 3 weeks for implementation. And then, of course, it has to go through the LIP process, through the voting itself. So that adds another week. So we're looking at about a month, I think, from once the proposal has been approved.
Cool. Thanks for the overview. So essentially, it's call reward once every 7 days instead of once a day, earn the reward for all 7 days. But the drawbacks of this are that there might be some lost rewards if people are changing who they're delegated to frequently, or they might have a longer waiting period before they earn their first rewards when they enter the system. If anyone has any strong reactions to those, feel free to share. I think those trade-offs are probably worth it, considering most delegators kind of show up and stake for a long period of time rather than constantly move their stake around anyway.
Yeah, it's true that this proposal, if it were to pass, slows down sort of the staking and delegation market. And indeed, it takes a longer time until your stake becomes active, so to speak. But we've also done some research on some metrics and how frequently people have changed delegators, how much staking action occurred. And it seemed that at current gas prices, slowing down the delegation market to a reward period of 7 days wouldn't really affect how the market already behaved in reality. So yeah, the trade-off seems worth it. I don't know if Jan has something to add on that.
Yeah, I think some good points that have been made. I think the one thing that I'd add about the slowing down of the delegation market is that a thought that has been shared is that generally that's like a trade-off that such a proposal would make, and in an ideal world, that trade-off would not be made at all. But due to some of the data around staking activity today, around the frequency, I think an interesting thing to consider is that the primary goal of this proposal, I think, is to help alleviate some of the cost burden on orchestrators who, I think it's probably fair to say, take on the brunt of the costs in the network relative to other stakeholders. So that's like the primary goal, and that's like the primary thing that the proposal is trying to achieve. In an ideal world, kind of delegators would be helped as well. But I think in this particular case, due to some of the limitations of what we're dealing with the costs of Ethereum today, that slowing down of the delegation market is looked at as kind of a temporary sacrifice that we wouldn't want to make in an ideal world, but knowing that we're also working towards kind of bigger and better scaling solutions in the medium term that hope to kind of remove some of these constraints from a design perspective, the hope is that it's a temporary sacrifice in the short term that shouldn't have too much of an impact relative to real world behavior, but that shouldn't be a problem in the medium term with the larger scaling solution as well. So I think that rationale is definitely also motivated by kind of that forward thinking, knowing that there is going to be this heavy work on that scaling solution after this proposal as well.
Cool. All right. So we'll look for the updates in the LIP issue and then can move it through the process. Any questions or comments on this specific issue from anyone?
Yeah, it's Chris. I have one question or one clarification. So the process from here is that the LIP would get approved and then this would be developed and then get into the code, and then we would see a release come after that. Is that right?
A slight clarification. I think the implementation work would be done before it gets approved, so that the during the voting period, everyone would know the backing implementation updates that would be made to the smart contracts. And then yes, if the vote is approved, then it would be deployed.
Got it. So is there anything we need to do now, or is there anything that needs to happen to kick off the implementation process?
I think Nico is going to publish some of the candidate design specs for how it would work, and then use that in order to kick off the implementation process. But there's no kind of approval needed or community action needed other than just input. And the more code review and auditing on any smart contract changes, the better.
Okay. Yeah. I mean, I'd be excited to get this in as soon as possible. So yeah, just trying to figure out if there's anything that we need to do to help that along.
Yeah, I think that's a shared feeling that the sooner this gets in, the more relief everyone's feeling in terms of ETH gas costs. But it's just with any smart contract changes that touch all the complex state updates, needs to be done correctly. I think we already saw in the last scaling update, which created a lot of fee savings for delegators to be able to claim and withdraw their fees and get up to date. We went through a pretty rigorous audit process with two separate auditors, I think, and we still ended up with a couple after the fact bugs that needed to be fixed and addressed. And this one seems less complex, but there's still some complexity to it.
Yeah, no, I can appreciate that. Thanks for the diligence on that side.
I just had a quick question. So Ethereum's EIP 1559 fee market overhaul is greenlit, I think, for July. I know it's like there's not like any assurances that this will decrease fees across the board, but I think there is a chance. Is it worth waiting to see how this affects the fee market before deploying this LIP?
Yeah, I think that's a good question. And maybe a good place to start there is, well, for those that are not familiar with EIP 1559, the basic gist of it is that it's going to change how users pay fees on Ethereum. And I'll leave kind of, it's a pretty technically detailed proposal, so I'll leave the details to kind of be discussed separately. But my understanding is that the primary purpose of that proposal is not, and it's not something that it can do in the first place. It's not going to like decrease the fees that you have to pay generally, because that's ultimately like, it's not going to blanket decrease the fees that you have to pay generally, because that's something that is controlled by just like the demand on Ethereum relative to kind of the supply, which is like EVM computation. But what it does help with is actually estimating the fee that you need to pay to get within a block. So right now, lots of users actually overpay to get into an Ethereum block, because estimating the gas price that you need to use is pretty hard. And it's really hard to have like a really accurate estimate, just by nature of like the price that you have to pay depends on what every single other user on the Ethereum network is doing. So I think it'll help with that, where it'll be easier to estimate the gas price that you'll have to pay. And I think there'll be certain cases where you pay less fees in that you stop overpaying. But I don't think we should expect like a blanket decrease in the transaction fees that users of Livepeer would have to pay, for example. I think some people will get some savings here and there because estimating the gas price will become easier and more accurate. But I think if we kind of continue to see rise in demand of Ethereum over time, that'll probably outweigh any savings that you get from more accurate gas price estimation. So that's kind of my 2 cents on the topic.
Yeah, I sort of agree. The gas price will likely be more stable over time. But I don't think we'll see a huge decrease. I think 10 GWh gas prices are something of the past. So I think it's worth it to not wait for July, considering that's still a couple of months. So I think it makes sense to go forward with LIP56 anyway.
Yep. So let's provide some, the best relief that we can in a temporary setting, and work towards bigger picture layer 2 scaling solutions. Looks like we've got Chris broadcasting his ID publicly. Okay, maybe I'm the only one who noticed that, but all good. Cool. So what do you guys want to talk about next? Do you want to talk about dual mining with ETH, or kind of GPU rig setup with Livepool with Nico?
Slight clarification: it's not on Livepool; it runs straight on the Livepeer network as an orchestrator.
Oh, okay. Exciting. All right, let's do that then. Let's walk through the example and the details of how you set up profitable mining.
Sure. Yeah, where to start? So I set up an orchestrator and transcoder. I think late January. Staked 200 LPT to it, not really a high amount. It's what I had lying around in a wallet. And as you can see so far, I earned 1.50 ETH in fees. And you can also see I haven't called reward because gas costs are just incredibly high at the moment.
Is there a screen share? Is there a screen share you want to be doing?
Oh, sorry.
Yeah. Yep.
Let me present my entire screen. So yeah, 200 LPT, 1.5 ETH in fees, and no reward calls. So how did I set it up? First of all, I run my transcoders from home. They're actually upstairs. And my orchestrator is run from DigitalOcean, from a droplet there. I think for location, I chose Frankfurt, which is reasonably close to one of the livepeer.com API ingest regions. For those who don't know, most of the demand currently on the Livepeer network comes from the livepeer.com API. And it has 3 ingest regions currently, if I'm correct, which is in Chicago, Frankfurt, and one in Singapore. So if you're relatively close to those locations, you are probably going to receive a little bit more work. So I decided to put my orchestrator in Frankfurt, which is pretty close to Frankfurt itself, probably. I'm not sure where the exact location is, but yeah. So this is the droplet itself with some statistics. I think I use an $80 droplet for this, which comes with like 16 gigabytes of RAM, 4 virtual CPUs. So yeah, it can handle the load pretty well. In terms of bandwidth, you can see it's currently pretty low, not transcoding much at the moment, but it has been reasonably over time. So how did I set it up? In terms of hardware, I bought 2 GeForce GTX 1070s, which are reasonably old. I'm not sure how old they are, but yeah, I purchased them for 400 euros from a gaming team, and they were barely used. They were even tested by them and benchmarked before they shipped them, which was pretty interesting. But yeah, I spent 400 euros on those. I think that's about $450, something like that, maybe a little more. The other hardware that I use is basically just some budget motherboard, CPU. I do use a 1200 watt power supply, but all in all of this hardware together cost me about 1,100 or 1,200 euros. So that's about, I don't know, $1,500, something like that. So as you can see, 16 gigabytes of RAM, a 1 terabyte SSD, which I don't really need for Livepeer, but I plan to run some other stuff on this as well, such as a Pocket Node. So yeah, basic motherboard with 2 PCI 16X slots and 1 PCI 1X slot. This slot is currently occupied by my Wi-Fi card because my transcoders actually run on Wi-Fi and not on a UTP cable. But everything seems to be going fine because I earned 1.5 ETH in fees. But yeah, performance could still be way better if I just ran a UTP cable. So yeah, this is my setup. This is just basically your standard desktop setup. It's just in a case with 2 GPUs. Cable management is a bit bad, so I can't close it up. But yeah, that's about it. Setup instructions, I followed the documentation basically. So you can follow that from there. The one difference being that I split my transcoder setup and my orchestrator setup. I'll show that in a moment. I think I had my configuration on this, but apparently not. I use a base price, so my price per pixel I set on the node is 4,000 Wei per pixel if someone is interested in that. And that seems to be doing well even under current gas prices. When the node charges a overhead based on the transaction costs, I still receive a considerable amount of work, so that seems to be going well. As you can see, I'm currently transcoding. These are the logs from my orchestrator. I don't have fancy monitoring set up. Maybe I should do that. Maybe I should read Firdanumery's blog and set that up. Something that I have to do still. This is my node from home. That's upstairs. These are my transcoders. As you can see, I have 2 GPUs. They're currently running at or using about 600 megabytes of their 8 gigabytes and pulling about 37 watts of their total 150 capacity. And I think the most I've seen them at was like 65 or 70 watts. So in terms of energy consumption, that's pretty reasonable. As you can see, I'm currently transcoding, but since last restarting my orchestrator, I think a week ago, or maybe a little bit over that, maybe 10 days, I've transcoded 330,000 segments without having to restart anything. So that's pretty good. Still running and probably still earning fees. So that's how I set up my node. If anyone has any questions, I'm happy to answer those. Oh yeah, in terms of bandwidth that I use at home, in case someone's interested in that, this is my usage in gigabytes per day, I think, over the last couple of days. It ranges somewhere between, I don't know, 40 and 180. So I think I average about 120 gigabytes per day in terms of bandwidth. My internet speed, maybe someone's interested in it. I think it's...
Yeah, what's your maximum upload or download?
It's not that impressive, actually, but it does the job for now. I can always upgrade to gigabit, but it's something about 280 download and about, I think, 30 or 40 upload. We'll see.
And have you noticed orchestrator busy errors on your orchestrator where there's actually more capacity available for you than you could handle, or no?
No, not really. I have my session limit set pretty high at, I think, 30 streams, which is a bit much for the 2 GPUs that I run, admittedly. But I haven't seen any errors, probably because I haven't received a huge amount of concurrent work. I think the most I've seen was maybe 6 or 7 streams concurrently. And it handled that just fine. So yeah, haven't seen much errors on that front.
Great. Yeah, it looks like you probably hit your bandwidth upload limit first. It looked like maybe it was capped at 25 megabits per second. So yeah, it sounds like your 6, 7, 8 streams might get you there depending on the renditions.
Yeah, that's true. Oh, the results. Oh, I have 30 megabit per second upload, so not that great. So I'll probably hit my bandwidth limits before I hit my GPU limits. So.
Yep. Awesome. Thanks for the overview. Any questions from anyone who's doing their own GPU rig setup? Yeah, well, I'm sure you're getting many questions in the Discord as people are following your blog post and working to set up their own infrastructure. So thanks for writing that post. Cool. All right, Yandin, you want to give an update on dual mining?
Sure. So I actually created a small collection of slides just to visualize a few things. So I'm going to share my screen and then get going. Cool. Can everyone see my screen right now? Just someone give me a thumbs up verbally.
Yep, we can see it.
All right. So where's that button? Cool. So this is a quick update on dual mining. And what is dual mining? When we say dual mining, dual mining in the general crypto context has often been referred to when talking about mining different cryptocurrencies simultaneously using the same piece of hardware. In the context of Livepeer, what we're interested in with Livepeer video miners is concurrently transcoding video on the same piece of hardware that you might be using for mining, let's say, a separate cryptocurrency. So before getting into some of the latest updates, I thought it might be helpful to just talk very briefly about the motivation here for some people on the call that might not be familiar with this, or if anyone watches the playback later, if they're not familiar with this. So I'll keep it brief. So from a big picture, why do we care about this? And the two questions that I mentioned here are, one, how can we improve the upside and sustainability of video miner operations in the Livepeer network? And two, how can we bring in more participants that already excel in certain areas, i.e. hardware, that are important for video miners? So those are two questions that I think are important for the network, for anyone that is operating hardware that have GPUs today. I think the upside and sustainability of their operations matters to them. I think that's safe to assume. And in terms of the long-term growth of the network, we're still at an early stage, but we're seeing increased adoption on the demand side, we want to make sure that the supply side can grow to meet that demand as well, whether it be through existing video miners or new ones that enter the market. So that's where dual mining comes in, where one of the things that dual mining tries to tackle is utilization of the GPUs. So, and then related to that is additional revenue streams. So there's one question around, can we improve the utilization of the GPUs? So are we really getting the most bang for our buck from the hardware that we already have? And the second one related to that is like, what is the additional value that we can get if we can improve utilization of the GPUs? And this, I think, is interesting for, let's say, a crypto miner that isn't familiar with Livepeer, but I think this is actually of particular interest to people on the network today, or people that could be joining the network tomorrow, because of this following point, which is the difference between more common types of mining, such as proof of work mining, and the type of work that you'll do on the Livepeer network, i.e. transcoding. And I think the next two slides will illustrate this a little bit. So this is kind of what a proof of work mining work pattern looks like. If you held all other things constant, if you have a piece of hardware and you don't change anything at all, you're constantly going to be doing work, and it's going to be at a constant rate. So there's never like nothing to do for you. So that's actually kind of nice from a utilization standpoint for a proof of work miner, because they know that like if they get a piece of hardware, it's working. It's a little different in Livepeer, right? Because the Livepeer marketplace is about matching video developers with transcoding capacity and generally video infrastructure. And this is a more demand-driven marketplace. So as with all demand-driven marketplaces, you have these peaks and valleys where there's not always work to do. There might always be work to do, but there might not always be the same amount of work to do. So you might have some days where there's just like a lot of traffic, and then some days where there's less traffic. And it might vary from a week-to-week basis and maybe on an hour-to-hour basis. So why does that matter? Well, some orchestrators have mentioned in the community, in Discord, for example, have mentioned and asked questions around, oh, why they're not seeing as much work during certain times of the day. Well, we can always improve the demand on the network by growing adoption, but this is also kind of just natural to these demand-driven marketplaces where we're going to have those peaks and valleys no matter what. And that's relevant because when you have a valley where you don't have a peak in traffic, that means that you're using the hardware that you already paid for and are already paying the costs around. You're not really using it all that much. So I think that leads to an interesting question, which is, well, how can we make use of that GPU during those times? So this is something that we've talked about in previous messaging, but what's interesting about transcoding is that one nice benefit of this workload is that the majority of transcoding happens on separate areas of the hardware and not on the area of the hardware that might be dedicated to, say, proof of work mining or some other heavy computation. So this doesn't necessarily mean that there's no trade-offs at play. It just means that there's some added benefits that you get from having transcoding being the other workload that you do relative to, like, let's say if you wanted to do proof of work mining for one coin and proof of work mining on another coin. I think you'll get more benefits with having transcoding being the second workload by nature of how the hardware is designed. So that's some of the motivation and some of the things that we've talked about in the past in this area. And next, I'm going to just give a brief rundown of some of the latest tests we've done internally to continue validating this idea, share some of the takeaways, and then share some of the next steps that we're thinking about. And then if anything's unclear, I'm happy to answer questions at the end. I don't think this will take too long. So in terms of latest tests, we spent some time with two particular GPUs recently, a 1660 and a 1060, both with 6 GB of memory each. And you'll see on this slide that I mentioned the generation of the GPU. One is a Turing generation, which is newer. The other is Pascal, which is older. And it'll become a little more relevant as I go on. But for now, just make note that they're from 2 different generations. We also use 2 different Ethereum miners. And the reason for this is that in the previous testing that we did, we focused on ETH miner listed here, which is actually the only open source miner that I'm aware of. But despite being open source, it's actually still fairly popular. It's not the most popular, but people still use it. But there may be some advantages of using a closed source miner. And a lot of the most popular miners are actually closed source. They have kind of their own payment structure and reasons for why they are closed source. But these closed source miners often have a bunch of different optimizations that you might not find in the open source version. So we focused on one example from this category, this miner called T-Rex, which is known to be pretty popular in the Ethereum miner community, and at least in our tests, performed a little bit better than ETH miner. So that kind of confirmed the slight speed improvement that we suspected. The next point I'd mention here is, and this links back to the generations. So I wanted to highlight the newer GPU versus the older GPU because in some work that we've done previously, we discovered that with newer GPUs, they're actually compatible with this special software from NVIDIA that basically attempts to improve parallelization of workloads, if that's what you're doing. And it's only supported when you're doing video transcoding on some of the newer models. So that's why we did a test with the newer model so that we can try out that software. And then also a test with an older model where we knew that we couldn't use that software because we know that miners and people acquiring GPUs, depending on their cost, depending on their budget, they might not be able to get the newer one. So they might just only have access to older ones. And then we considered 3 different metrics. So hash rate. So this effectively measures kind of the output for the proof of work mining workload. Transcoding speed, which effectively measures the output of the transcoding workload, how fast we can do it, because we know that we want to do it fast in order to get it back to the people on the other side of the marketplace quickly. And then transcoding capacity. So speed and capacity are related, but should be treated as separate things because it's one thing to transcode really fast, and it's another thing to be able to transcode many streams simultaneously. Now they're related because your speed can impact your capacity, but your capacity might also be impacted by other things as well. So those are the 3 metrics that we considered. And yeah, I might just show very briefly a spreadsheet with some of the results that we've been compiling. It's kind of messy right now, so that's why it's not included here. We're looking to compile everything in a cleaner format to share in the forum soon. But just to give you an idea of some of the tests that we did, we first wanted to know how much transcoding could we do on a GPU with just a single workload. So I think the thing to look at here is in this table, we kind of measure the ratio of time. So transcoding time relative to the size of the video. And we did that for multiple streams, and we ran a bunch of trials, and we ended up concluding that there's a nice sweet spot at 16, where if we have 16 streams or 16 sessions, we stay well within kind of 0.8, which was a little bit of an arbitrary threshold that we decided on, but it roughly corresponds to transcoding 20% faster than real time. Where why would you want to do that? If you do that, then you have a small buffer so that you can actually get that data back to the other person quickly as well. So 16 streams, we stay well within that. When we get to 17, we go above that. So we decided 16 was the sweet spot. And we ran a bunch of trials across the different miner software that we're using. And then we also did some trials where we were doing transcoding and mining simultaneously. So the one result that I will highlight here is this table. So this table should highlight the best results that we got when we were doing the mining and transcoding simultaneously. And what I'll highlight is that in terms of transcoding capacity, we maxed out at 6 streams. So that's a good amount lower than the number that we saw when just transcoding standalone, and we can come back to that. But I think the interesting things here are that the ratio that we got was still pretty good at that 6 streams. So we were actually transcoding pretty fast throughout this process. And our hash rate, so for Ethereum, dropped a little bit. But if we look at kind of the original results for mining without transcoding, there's a bunch of numbers here, and I think the one that we want to look at is probably the default. So the default was 20.79, and when we are maxed out transcoding doing this setup, we are in the 17 to 18 range in terms of hash rate. So there's a drop, but it's not a gigantic drop, it's a small drop. So I think those are some interesting results. And so we saw that transcoding speed was impacted, but we were still able to transcode fairly quickly. And hash rate was impacted, but it wasn't a gigantic hash rate drop. And what was impacted was the transcoding capacity. So we went from 16 to 6. So that's probably the most interesting thing to focus on. So going back to the slides, those are some highlights of the tests, and we'll share the results in full after cleaning them up a little bit. So I'll move on to the takeaways. So some of the takeaways that we had from this experience, starting with this third one here, is, well, why did we go from 16 to 6 in terms of transcoding capacity? And the reason is that we're actually constrained by memory on the GPU. So it's actually speed that's the problem. It's the amount of memory that we have on the GPU. And this is because Ethereum mining by default takes up a large chunk of memory, and it kind of just eats it up. It won't budge. It's not adjustable, non-negotiable. It just takes it up. So that's why we saw the transcoding capacity impacted. But we were still able to get able to eke out 6 additional streams with some hash rate loss, some transcoding speed loss, but both of them may be acceptable. So I think the biggest thing to take away is that the capacity is constrained by memory when we're doing this pretty simple setup, but we're still able to eke out some additional work for this additional workload. Now, related to that is, you might be thinking, well, if the transcoding capacity is impacted in this way, does it make sense for someone to do this? And I think the answer is it'll depend on you. It'll depend on the user. So things to consider are how many GPUs you have. So if you have a lot of GPUs and have a large volume, in sheer volume of number of streams that you'll be able to handle, it still might be a lot. So I think how many GPUs you'll have matters, and some other factors that we can maybe talk about if people are interested in. But the one last thing I wanted to highlight here was that depending on the user, there might be more practical ways to explore this type of setup outside of what we did in these tests, which was just doing everything simultaneously. And one example is you could switch between the workloads dynamically. So instead of just doing everything simultaneously, which is kind of like the simplest, naive way to do it, you could switch between them and say that if this one is more profitable, or I'm getting more work here, I'm going to do this one. And if I have a very low volume of work here, I can spend some time doing the other one to make sure that I'm always earning with my GPU no matter what. And I can adjust depending on if I'm going to get more work in one area than the other. And the cool thing is that it would be possible to build a tool like this today, I think, given kind of the existing software that exists in both the Ethereum mining ecosystem and also the Livepeer ecosystem. It's not built yet, but it should definitely be possible. So if any of this interests you and you'd like to experiment with this, definitely get in touch. I think people would be happy to support this, and it'd be great to get something open source so people can play around with it as well. So that's that. And the last 2 takeaways are around recommendations. So I'll keep this brief, where We talked about newer GPUs versus older GPUs. If you're interested in doing this, you should definitely take this into consideration. So if you have a newer GPU, we would recommend at the moment using that CUDA MPS software from NVIDIA and using a miner like ETH miner, not necessarily ETH miner, but ETH miner is an example here that gives you more control over GPU workloads. So the nice thing about ETH miner is that it exposes some configuration that gives you more control over the GPU workloads. And that ends up being important for CUDA MPS, which if people are interested in, we can talk about later. And if you're using an older GPU, it's less important. So if you're using an older GPU, I think the general recommendation right now is use T-Rex, which we've already successfully tested with, or any miner that is known to work well with your GPU. The thing with Ethereum mining is like some miners perform better depending on the model that you have. And I'm not sure that there's necessarily a standard best in all categories. So those are two recommendations that emerged from our testing as well. And to wrap up, so we learned a lot of things from this experience. And in terms of next steps, what we're planning on doing is we're working on some new revamped docs that we're hoping to ship later this month. And those revamped docs will include some guides and some getting started material for people that like to experiment with these setups themselves. We're going to share these test results in the forum so that it's a little more digestible than kind of the mess of numbers that you saw previously. And some of the team members are also planning on experimenting with this setup in production on the network as a small case study. So dedicating a small number of GPUs to kind of see this work in action in the live network and create a case study out of it so that more people can learn from that and use that as input if they want to experiment with it themselves. So yeah, that's a summary of some of the latest that we've been doing in this dual mining area. And I think that wraps up my update. So thanks for bearing with me, and happy to take any questions or discuss anything that came up during that presentation.
Just for clarification, is it correct to state that the amount of memory reserved for mining is the DAG size for Ethereum or whatever coin you're mining at that time?
With the case of Ethereum, yeah, it's that memory consumption is caused by the DAG.
I see. So your transcoding capacity will decrease over time, right? But I think it's a pretty slow increase. I think 8 GB is not set to be reached until something like 2026 or something. So I think that's a pretty slow process, although it also provides an interesting opportunity when the 6 GB cards become redundant and what they'll do to keep earning revenue, of course.
Yeah. So I think one interesting thing is, and this gets to like some of the practicalities of this, depends on the user and what they already own. So if you are already memory constrained, then this may not be as attractive to you, but it might be particularly attractive to someone that has a lot of surplus memory. So some of these cards on the market have upwards of 12, 16 gigabytes of memory available. I think I've even heard of like 24. So that's if you're using that for mining, like the amount of surplus memory that you have is pretty large. So that's like a opportunity for them, right? And then I think your other point's interesting too, where I think with Ethereum specifically, we'll see more and more cards become useless. So this could be a useful thing for them to take a look at as their cards become useless.
One other thing I'd be interested in, if someone were to build a tool that allows you to swap between transcoding and mining, depending on whichever is more profitable, is benchmarking on what it takes to load the DAG into memory and remove it back from memory, because that has to happen in order to free up that memory for transcoding, I guess.
You're asking if that would be a part of the benchmarking?
No, I'd be interested to see how efficient or inefficient that would be in the entire process of having to load that file back to the video RAM.
Yeah, that's a good question, and don't have an immediate guess as to like any implications to it, because it does take there's like a warm-up time in order to get it in there. So yeah, that'd be an interesting thing for someone to look into if they wanted to build a tool.
Right. If you were mining and then a segment of video arrived and you made the decision right there to drop the mining in order to transcode, could you actually in sub real time encode that segment and get it back in order to retain the job for the next segment? That's like I don't know, did this experiment reveal that answer, or that's a separate experiment?
So if we're just talking about like a single stream, then with the GPUs that we use, yeah, you would be able to do that. Like your capacity is reduced, but so the number that I think I mentioned was 6. So just as an example, like you'd still be able to transcode 6 streams concurrently in like pretty fast. Like you'd be able to transcode them pretty fast, so that's not a problem. So what this might look like is like you can do both simultaneously, but you set some threshold where like it's before the breaking point, where like if I reach this threshold, then I can kind of start the process of shutting things down. And then if I kind of come below the threshold, I can start the process of bringing things back up.
Yep. Cool. So it as long as you're mining profitably and that potential 2 mega hash per second drop doesn't mean that you go to unprofitable mining. Well, I guess that doesn't even matter because you're replacing the income with video encoding. So as long as the video encoding revenue, surpasses the drop in revenue from mining there's very little reason not to run a setup like this.
Yeah, I think that's accurate. Yeah, what's interesting is that, so the thought that came up was like, well, if you're like speculating on ETH, then there might be interest in like keeping your hash rate up. But at the moment, you earn an ETH in Livepeer as well. So that's a little less of a concern there. It might be different if like, let's say you were earning 2 different currencies.
Yep, good point. Awesome, great update. Yeah, it'll be good to package all this up into both, consumable results, but also, the right tutorial or steps or guides for people to take to be up and running with these miners.
Cool.
What do we think? Oh, sorry, didn't want to interrupt.
Go ahead, Nico.
What do we think some of the unknowns are for miners to use this setup? I'm thinking about maybe power consumption, bandwidth costs. What could be some other things?
Yeah, I mean, definitely. So that's not really mentioned here, but yeah, obviously bandwidth costs is a difference between Livepeer and what a traditional miner would do. So they should factor that in as well into their calculation of whether they want to do this. In terms of power consumption, this wasn't the most like rigorous of testing, but I think it was good enough. But in our good enough testing, I don't think that there is much of a difference between. I think there was a negligible difference in like average power consumption when you were doing both simultaneously versus if you were just doing mining. So from a miner's point of view, if that is true, then assuming that's true, then I don't think that's a huge concern for them. It would be more of a concern the other way around. So someone that's just transcoding right now, diving into this. So if they are doing that, then they should start thinking about how they set up like cooling for their GPUs and some of the things that miners have to think about. So yeah, I think it matters what direction you look at it from.
Good point. Just because you're transcoding on Livepeer profitably doesn't mean that you can mine profitably due to electricity costs and efficiency of your hardware.
Right. Yeah. So I think that's an area where like if anyone on this call or like other people in the community are interested in and they don't have experience with like kind of the technicalities of mining, that's something that I would encourage people to do their research on first, because you'll likely have to think a little more about how you manage your hardware if you want to do this consistently.
Honorable mention for EIP 1559 and changes to potential miner income here as well, although for Ethereum.
Right. I suppose along the same lines of cards becoming useless as the DAG side increases, right? So as if the income of miners decreases after EIP 1559, that changes kind of their calculus for what else they might do with their GPUs. So good point.
Cool. And then hanging over all of this was a recent NVIDIA announcement that they're actually splitting their development track for gaming specific GPUs that will have ETH hash mining disabled or broken by default, and then mining specific GPUs, which we don't know whether they'll have video encoding hardware on those cards or not, but suspect not. So we'll see how that whole track develops and what impact that has to both the mining and video encoding ecosystems.
Yeah,
Maybe they will go. Oh, sorry. Go ahead.
Oh, it's an interesting time to be talking about GPUs and like the hardware landscape. And I feel like Livepeer is in a interesting area of that ecosystem as well, and kind of hopefully over time as well, kind of, I guess it complicates the decision that someone has to make, but because there's just more and more options for things that you could do with these things. So yeah, interesting time to be in hardware.
All right, so I think we're at the top of the hour here. Thanks very much, Yandin and Nico, for driving a lot of this presentation. Hopefully this content was useful to everyone running nodes on the Livepeer network. I know a bunch of people are watching the live stream. Feel free to ask any questions in Discord or the forums, and look for some posts coming soon summarizing some of these recent results, tests, and tutorials for how to get up and running with these setups. All right, thanks everyone. We'll see you soon.
Thanks, bye.
See you, everyone.